Hello, Mr. Westwater here, and in this video I thought I'd just quickly go through why Pascal's triangle appears in the binomial expansion. We often you see it being used, but there's sort of this underlying question of, is it coincidence? Is it inevitable? Did the triangle come about through the binomial, or is it just one of those mathematical things that happens? Okay. And, a lot of you will probably realise that the result is inevitable. However, by looking at the binomial process itself, we can really understand why. Okay, so I'm going to start off by just thinking about what it is to be, or to multiply by a binomial, to multiply by a bracket with two things in it. Okay, so if I have a plus b to the power of 0, we're happy that this just equals 1, anything to the power of 0. Now, if I raise this to a higher power of 1, then I am timesing the result, the previous one, by a plus b. And in our binomial expansion, that's essentially what's happening all the time. A plus b squared is taking a plus b to the 1 and timesing it by a plus b. So that's how I've written it down here. A plus b cubed is taking a plus b squared, our previous one, and timesing it by a plus b again. And whenever we have these things, or we multiply by a binomial, the important thing to remember, and let's do this in a slightly different colour, is that this a term will multiply everything in that other bracket, whether it be two terms, one term, or more, and the b term will also multiply everything in there. So in a plus b to the 1, all you've really got is a plus b times the previous result, which is 1, which is why we end up with 1a and 1b. Makes sense. Whereas in a plus b squared, we end up with the result a squared plus 2ab plus b squared. Now, when we move on to a cubed and higher powers, it's important to remember that this first term, this a plus b, is multiplying everything inside. So a is multiplying a squared, it's multiplying 2ab, and it's multiplying b squared. And the b is doing the same thing. And what this means is all of these terms that were there originally are going to gain two new results. You'll have everything here multiplied by a, so you've got that a cubed plus 2a squared b plus a b squared, and you'll have everything multiplied by b, so a squared b plus 2ab squared plus b cubed. Now, what this you may see this already, what this means is that naturally, as you work your way down the binomial, sort of Pascal's triangle, you will get a natural evolution of the binomial expansion. And just to sort of show it really taking effect, I'm going to write out the Pascal's triangle with the binomials in them, and let's just remember that this was a plus b squared, wasn't it? Okay, so a plus b cubed, so a plus b is going to be a plus b times a plus b squared. And so let's think about what's happening here. If I think about what's going to end up giving me a squared b, well, that's going to be the result of this a multiplying the ab term, so this term up here. Yes? And what the only other way I'm going to get an a squared b is when my b term multiplies the a squared term from a plus b squared. So these two will always combine to give me the next term. The result of it being within Pascal's triangle is inevitable. Okay, let's just have a look at it one layer down. So let's have a think about a plus b times a plus b cubed. Okay, well this will mean, remember this row up here is a plus b cubed. If I think about my a to the 4 term, well that's only going to result by a timesing this a cubed term. So again we'll have to end up with 1a to the 4. Now if I think about the a to the a cubed b term, well that can result from this a multiplying my a squared b from a plus b cubed, or it can result from the b times my a cubed term. So naturally we're going to have a result of 1 plus 3 a cubed b, which is 4a cubed b. Okay, and similarly, if I think about the a squared b squared term, that can result from the a multiplying the 3a b squared. That will give me an a squared b squared term, and therefore 3a squared b squared. Or it can result from my b times 3a squared b, again giving me plus 3a squared b squared, so the result will be 6a squared b squared. And so it's not a coincidence, it is inevitable. It's not a case of what came first, Pascal's triangle or the binomial expansion. They sort of exist together, okay? And when we think about one, the other becomes inevitable, okay?